Hello, Mathemaniacs. I'm the Math Edumacator, and today we're going to begin a series of videos on various mathematical topics and concepts. Today's video is an introduction into a mathematical topic called set theory. Set theory is the beginning of mathematics, not historically, but logically.
Say that you're in class. The teacher's explaining some concept, and one of your classmates has a question. Why? The teacher may go and try and explain that concept in terms of something that he or she has previously talked about. Now, in that case, it's possible that the student might have a question about those concepts. And so what you get is you can get a series of questioning going back in terms of a logical progression. So if the teacher is talking about concept A, the classmate asks a question, the teacher tries to explain A in terms of B, but the classmate has a question about B, the teacher explains B in terms of C, and so forth and so on in a sort of logical progression. But at some point, there is a beginning. So if you trace anything back far enough, then eventually you get to the beginning of whatever topic the teacher is talking about. And in math, this beginning is called set theory. Everything that's in math ultimately relates back to set theory if you go far enough.
Well, if set theory is the beginning, then what do we have to work with? Well, nothing really. We don't have algebra, we don't have operations, we don't even have numbers yet. So what can we do? Well, what we do is we set up a system of organization. Normally, in math, things are very rigorously defined. However, in this case, we don't have anything to define with. So what we do is we establish a few things that we call primitives, which are things that are not rigorously defined mathematically, but we have just sort of a general understanding of what they are. These two things are sets and elements. A set is a collection of things, and elements are the things inside that set. See, that's not so hard. Seems pretty straightforward, but this organization is actually fundamentally important, not just in mathematics, but in all kinds of things. Basically, you can think of sets and elements as categories and things inside those categories. For example, suppose that my category is different colored Sharpies. Well, what are some things that would be in that category? Oh, we've got blue Sharpies, red Sharpies, green Sharpies, orange Sharpies, purple Sharpies, all kinds of things. Suppose our category was soda. Well, one of the things inside that category would be Pepsi. So in this case, soda would be the set, and Pepsi is one of the elements in that set. Basically, the idea of sets and elements is so important, it's used in every other field, not just in mathematics. In English, we break down words into different categories, such as nouns, verbs, adverbs, adjectives, pronouns, things like that. We could have continents, and then all of the countries that are part of those continents. In science, we classify animals, and so we have different classifications, so different kingdoms or phylums, and we have animals that belong to those categories. So if every topic or class uses categories, what's so important about set theory? The main difference is that all subjects use categories, but in math we actually study categories. We actually talk about how things are organized within categories. And because categories are so universal, we can talk about using a wide range of examples. One of the main ways that we depict sets in math visually is with something called a Venn diagram. In a Venn diagram, I can use a circle to represent a set. And so I use something like this. So I've got a set here. We're going to say this is snacks that contain peanuts. Now I have another set here. This is the set of all snacks that contain chocolate. And so what I do is I put it next to my first set, but there's a slight overlap between them. And let's say that this represents a Hershey bar. Well, a Hershey bar is a snack and it contains chocolate. So what I do is I just simply put this inside the circle that is representing my set of chocolate snacks. So we drop it right here. I say this is a Reese's peanut butter cup. Now a Reese's peanut butter cup contains chocolate and peanuts. So what we do is we put it in the overlap between them so that it's both inside the chocolate circle and inside the peanut circle. So this is like the example we just demonstrated, where we have a circle for chocolate snacks, a circle for peanut snacks, and then we have labels for the individual snacks that we came up with. Hershey bar in the chocolate snack circle, and Reese's cup inside both circles. But there's other ways to use Venn diagrams like this. Basically, the important thing is we use the circles to indicate belonging. So in this example, we have a category of shapes with 3 sides. And so everything inside the circle are things that have 3 sides. Shapes have 3 sides, like right triangles and isosceles triangles. Any kind of triangle, basically. And everything outside are things that are not shapes with 3 sides. So we have squares, pentagons, and hexagons. And those are just some examples, but any shape that doesn't have 3 sides would be outside the circle, including actually circles, because so you'd have circles outside the circle like that. If you have 2 categories that don't overlap at all, then you simply draw the categories to reflect that. So you have 2 circles that are completely separate. So you have cars made in the US and cars made in Europe. Now, so long as you specify that we're not talking about cars that were made partway in Europe, partly in the US, we're talking about, say, when the car is actually finished, then you can't have something that's in both of these categories. You can't have a car that was both finished in the US and finished in Europe. So that's why these 2 categories would be separate. And for many other categories, there is overlap. And so that's why most Venn diagrams you see will look like the one that we had before. Now, a Venn diagram is a really powerful tool, and you can use it for things like comparing and contrasting. So most of you have probably, in English class, you've done comparing and contrast, say, characters in a story. So, or between 2 stories. So what you would do is you would have one circle for the first character and another circle for the second character. Everywhere where the circles overlap, you would write down traits that both characters have. In this part here, you write down traits that only character 1 has. And in this part here, you write down traits that only character 2 has. But again, everything that they both have would go in this section here. And so it's a very powerful tool for organizing. And most likely, even if you don't know the term Venn diagram or things like that, you've probably used something like this. And that's all we have on set theory for today. Next time, we'll go into some more detail on set theory, including how numbers actually become involved for the first time. I hope you found this video informative. If you did, please hit the like button. If not, you can hit the dislike button. If you wanted to ask me anything, please comment below. If you want to see more Math Edumacator videos, please subscribe to my channel and follow me on Twitter at Math Edumacator. Thank you. Have a great day.